Hey everyone. So now that you've had an opportunity to reflect on what you already know about perfect squares and simplifying radicals and square roots and all of that, we're going to do some practice and examples, and I want to make sure that we're clear on kind of where we're going with this. So the first thing that I want to talk about is what is a perfect square, right? That's something that we need to know in order to be able to simplify square roots. So a perfect square is a number that can be expressed as the product of two equal integers. So what does this mean? Right? So what's product? Oh, multiplication. Right? So it's the product of two equal integers. Right? And integers like 1, 2, 3, 4, 5, 6, 7, 8, right? So, well, 1 times 1 is 1. So that means 1 is a perfect square. 2 times 2 is 4. So that means 4 is a perfect square, right? I'm finding the product of two equal integers. 3 times 3 is 9. So 9 is a perfect square, right? So then maybe this rings a bell as to what exactly is a perfect square. So let's write some out. Let's go in order, right? We already started these. 1, you've got 4, right? So 2 and 3, not perfect squares. It's not the product, the result of multiplication of two equal integers. So 1, 4, 9. Well, what comes next? This is 3 times 3. Well, 4 times 4 is 16. 5 times 5 is 25. What's next? 6 times 6, 36. And the more you work with these, the more they will become second nature, right? So maybe they're not something that sticks out in your mind right away and you need to spend more time with it. That's totally fine. But the more you work, just like anything, the more you work with it, the more you keep seeing it and exposing yourself to it, you're going to know it better. Right? So 7 times 7, 8 times 8. And that's why I like to write them out. And sometimes I like to write them out at the top of my paper or just continually write them out so you can keep referencing them. So this is 8 times 8. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12, 144. Maybe some you're like, oh, I knew that one, right? Like 100. So maybe that one you knew. 13 times 13 is 169. 14 times 14. Is that what I was on? I think so. Yeah, 196. 15 times 15 is 225. 16 times 16 is 256. Let's do a few more. 17 times 17 is 289. Right? And so on. Right? So these are numbers that are perfect squares. If I asked you a question and said, hey, what's the square root of 16? Your answer would be 4. Right? Like you get a nice result from that. Right? If I said, hey, what's the square root of 144? You get 12. Right? There's nothing left over. This is 12 times 12. Okay. So what happens if the number I give you or the number you see that's the result of something and you have to go take the square root of it is not one of these perfect squares? It's somewhere in between, right? For instance, 12, right? The square root of 12, right? We had a square root of, I think we had what? We knew the square root of 9 and we knew the square root of 16, right? So I know, right? This is 3 and this is 4. 3, 4. So I know this is going to be somewhere between 3 and 4. It's actually not a rational number, meaning it can't be expressed as the ratio, a fraction, of two integers. Right? So it's not going to be a nice number. So what we're going to do, instead of just turning to our calculators, right? I haven't mentioned a calculator, we're not picking one up. We're going to break this up, right? Some of us know this as factoring, our favorite thing. So we're going to think about, well, what numbers do multiply to 12? And maybe there's a perfect square that is a factor, right? Think about all those perfect squares we wrote out. A perfect square that is a factor of 12. So factors are going to be numbers that are smaller. So what two numbers multiply to 12. Well, 3 times 4. Right? So this is the same thing as the square root of 3 times the square root of 4. Or the square root of 3 times 4. I haven't done anything. The way this property, or I'm sorry, yeah, the properties of radicals work is this is the same thing as saying the square root of 3 times the square root of 4. Well, you know this. What is the square root of 4? 2. Square root of 3, not a perfect square. That's prime. It doesn't simplify anymore, so this is actually 2 root 3. And if you want to check that out in your calculator and check, does the square root of 12 equal to 2 root 3? You're going to see that these two here are equivalent. So this is the simplified version. Right? So we're simplifying square roots. We're simplifying radicals as much as they can be simplified. So what about this one, the square root of 343? Right, so if you go into your calculator, you type in the square root of 343, you're going to get 18.52, blah, 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 blah. It's not a nice square root. So we want to think about some numbers that are factors of 343. Right, so they're going to be numbers that are smaller than 343, not bigger. So think about some perfect squares you know. Right, and you can go ahead and see, like, what does 343 divide by? Does it divide by 16? No. Does 343 divide by 25? No. Does 343 divide by 36? No. 343 divide by, what else do we have? 49. It does. So this is the same thing as saying the square root of 49 times 7, which is the square root of 49 times the square root of 7. Well, what's the square root of 49? 7. So this is the same thing as 7 root 7. Okay. So why don't we do some practice? So if you feel comfortable, I think this is a great place to pause the video and try these on your own, or watch for another few and then try it on your own. I'm going to do this in 2 different ways. I'm going to do the odd ones, the left column, in a slightly different way, then I'm going to do the right one. So these 4, I'm going to do exactly as I just did with my other 2 examples. These I'm going to do, sometimes I call this as the tree method. So I'm literally just going to start dividing it in half, or dividing it by whatever number I can. So I've got 2, and what is 96 divided by 2? 48. Sometimes, if the other way works for you, do it. But if it's not and you want a new way of doing it, let's try this out. Let's divide it into again. 2 and 24. Keep going. 2 and 12. 2 and 6. And then 2 and 3. So square root. Square is pairs. So I'm going to look for a pair. Here's a pair. So if it has a pair, it can come out of the radical. It can, like, break free. Here's another pair. Oh, it can break free again. Right? So that broke free, that broke free. Ugh. These are left over. They can't break free. They've both got to stay under the radical. So here I've got 4 root 6. Right? So it's a little bit of a different way to do it. Here I'm just going to look. I'm going to do this one the other way. What is a perfect square that goes into 216? 4. 4 and 54. Right? So this is the same thing as the square root of 4 times 54. The square root of 4 times the square root of 54. This is 2 root 54. Let's just make sure. Does 54 divide by anything that's a perfect square? Does 54 divided by 16? 54 divided by 9? Oh, it divides by 9. Right? So this now I've got 2 times the square root of 9 times 6. So it wasn't, I didn't find the largest perfect square. I just found a perfect square. So 2, what's the square root of 9? 3. And the root 6 stays. There is no perfect square that's smaller than this. That's a factor. So I end up with 6 root 6. right? So even though I simplified it, I didn't simplify it completely, right? I didn't simplify it as much as I can. So maybe you realized right away that, what is that? 36, I believe, must be a factor of 216, and you got it right away, and you got 6 root 6 immediately. And maybe there's a faster way that you've done this, and that's fine. Okay, I'm going to finish these up, and I would encourage you guys to pause it and try it on your own. So 98 divided by 2, I get, what is this, 49, and oh, isn't 49 a perfect square? So this is 7 and 7. There's a pair. So this is going to be 7 root, the 2's got nowhere to go. I'm going to keep going with those ideas. So 2 and 36. 2, maybe you realize it's 6 and 6, but that's okay. 2 and 18, 2 and 9, 3 and 3. So we're looking for any pairs. A pair of 2's, write it down. A pair of 3's, write it down. Oh, this 2's got nowhere to go, so it's going to stay. 6 root 2. 45, that doesn't divide by 2, but it divides by 5, doesn't it? 5 and 9. And then 3 and 3. Oh, there's my pair. 3. The 5 can't go anywhere. Let's finish these up on the right. Square root of 18, let's find the largest perfect square. 9 times 2, right? So that's the square root of 9 times the square root of 2, which is going to be 3 root 2. Oh, what's the largest perfect square here? Isn't that a perfect square? I don't know why I'm rewriting it. So this is just 12. Those are always exciting. What about here? It ends with a 5, so I feel like I'm going to try 25. Yep, 25 and 7. So it's the square root of 25 times the square root of 7. So this is going to give us 5 root 7. And I encourage you to check with the calculator. See, does 5 times the square root of 7 equal to the square root of 175? Do you get that same crazy decimal? But I don't want you to rely on them. Notice none of my answers are decimals. So hopefully this gives you an introduction. I'm not expecting you to be a master right now, but just an idea of where we're going when we come back